protocols. First of all, we should understand what is an agreement in a distributed environment. Okay. The agreement says that where there is a number of systems which are geographically distributed, which are all cooperatively working to achieve a common goal. It is required that every other individual local sites must reach a mutual agreement in order to take up any decision. Right? For example, every data manager at individual site must agree upon whether to commit or abort a transaction. For example, in site 1, here is a site S1 and there is a site S2, where in S1 account A is maintained, in S2 account B is maintained. If suppose an amount is transferred between A and B, for example, this is amount transfer, for example, 1,000 rupees, right? So when there are two sides involved in this transaction, so here what should happen? The 1,000 must be debited from account A's account and it should be credited with the B's account, right? When this complete processes get over, then only the commit should happen. A should commit as well the B, right? So that should be a concurrence between the site S1 and S2, when to commit and when to abort a transaction, right? So this is what we call mutual agreement. Right? So the entire process of reaching an agreement is called agreement protocol. We need to have a protocol. If everything is happened in one particular site, we need not to have such a kind of agreements and a separate protocol for managing this kind of agreement, right? But where there are number of process distributedly in different sites, then there is a need for an agreement, mutual agreement, and the protocol which makes the process of mutual agreement is called agreement protocol, right? And one more thing is, in agreement problems, always there are non-faulty processes in distributed system should be able to reach a agreement, right? Excuse me. Able to reach a common agreement even if certain components in the systems are faulty. So what we can understand by this point is there could be a number of non-faulty, there could be a number of processes, but few of them may be faulty and most of them may be non-faulty, right? So the problem of agreement here, non-faulty processes is focused only on non-faulty processes, right? Which could able to reach a common agreement. Even the faulty processes are allowed to be there and they may confuse the decision. But here the challenge of the protocol is overcome the wrong direction or misunderstanding and to avoid any misdirection by the faulty processes, right? So the challenge is to be overcome. That is what agreement, an agreement protocol, right? In general, in any agreement environment, distributed environment having agreement protocol, the fault is assumed. The fault is assumed. Agreement protocol where and the faulty processor may send any spurious messages to any process, other processors, right? So there are faulty processors. They may send spurious messages, means wrong messages. By intentionally they can send messages okay, to any other processes, and the faulty process may lie, right? And they may not respond to other processor messages correctly, and even they can the non-faulty processor do not know which are faulty processes. Okay, so these are the assumed environment, right? There could be any number of faulty processor in the system and they may send any messages wrongly and they may lie or they may not respond to other processors messages, and even the non-faulty processors do not know which are faulty processes. These are all in general assumed. And we have a system model when developing a agreement protocol, right? The model of the system says there are n processors, right? That could be n processors, and at most m of them could be faulty. So there are n non-faulty processors and m faulty processors in the model. And the processors, either faulty or non-faulty, can communicate directly with other processors by the way of message passing. Here, how the processors are communicating? By passing messages, right? So that the system is logically fully connected. The receiver processor always knows the identity of the sender, right? If suppose a message is received at a processor, so that processor who receives the message always knows where it comes from. And one more assumption here is the communication medium is reliable. Only the processor may be faulty, but the medium is reliable, right? Only the processors are prone to failure. This is what actually the assumption on system model. This is what actually the confined model we have, where we are going to talk about the agreement protocols, right? And one more thing is the synchronous model of computation is also assumed. There is no asynchronous communication. You know what is synchronous and what is asynchronous? In communication, computations are all synchronous, right? Now, coming to the model of failure, processor failure. There are three failures of processor taken into consideration. One is crash fault. One is crash fault. What is crash fault? A processor stops functioning completely and never resumes back. It's called crashed. Processor crashed. And omission fault. Omission fault is the processor omits to send messages purposefully or non-purposefully, whatever. And malicious fault. Malicious fault represents the random and arbitrary behavior of any faulty processor, right? Arbitrary behavior. For example, intentionally the processor acting malicious activities, right? And malicious fault always to be taken into a broad sense in nature, and whatever it is called as Byzantine fault, the malicious fault in false, it is malicious fault. Okay. Coming to the next terminology, which is authenticated versus non-authenticated messages. So far, we are discussing about the preliminaries and the concepts, what should be aware of before entering into agreement protocol. Please be clear. So now authenticated versus unauthenticated or non-authenticated messages. In authenticated message, the processor cannot forge a message or change the content of received message. Such a message is said to be authenticated message, and it also can be referred as signed messages. In non-authenticated message, the processor can always forge a message. For example, if a processor receives 1, but it says that it received 0, right? That is what actually called non-authenticated message. This is also referred as oral messages. The authenticated messages are said to be signed messages, and non-authenticated messages are said to be oral messages, right? So these are the two things we have to know. And coming to the major part of the agreement protocol, the agreement protocols are classified into 3 groups. One is Byzantine agreement problem, right? In Byzantine agreement problem, a single value, right? A single value to be agreed upon between all the processors. And also the single value which is initiated by an arbitrary processor, right? And all non-faulty processors must agree on this single value. This is what Byzantine agreement problem. Another class of agreement problem is consensus problem. Here, every processor has its own initial value, right? but all other non-faulty processors finally must agree on a single common value. And the third class of problem says interactive consistency problem. Here, every processor has its own initial value as like consensus problem, but all non-faulty processors must agree upon a vector of common values, right? Okay, so this is what actually the three class of agreement problem. We have to keep in mind Byzantine agreement problem is the one which is talk about the single value initiated by an arbitrary processor and should be agreed by all the other non-faulty processors. In consensus problem, every processor has its own value, but the protocol must make any one of the single common value to be agreed upon. But in interactive consistency problem, every processor has its own initial value, but the agreement will be a common list of vector of values. Okay, so that's what actually the classification agreement. So classification of agreement protocols. Let's see one by one. The Byzantine agreement problem first. Byzantine agreement problem says the source processor is an arbitrarily chosen processor. Always where there are number of processors involved in agreement, the one source processor which is sending that initial value, no single value. So that's what the source processor is, which is arbitrarily chosen. Any processor can be a source processor. Processor broadcasts its initial value to all the other processors. The solution should meet the following condition. For in case process, right? All the other processors are there. Right? So this is process 1. This is process 2. And this is process 3. And process 4. Right? So here, as per the Byzantine problem, suppose if process 1 is the source process, which is chosen as arbitrary. So this process P1 is going to select the initial value. For example, 1 abdina, it will broadcast to all other processes in the system. 1 வந்து broadcast பண்ணோம். இங்க all the other process must agree upon this one. Right? That's what the problem here. Right? Now, here the condition should be met. One is if all non-faulty processor agree on the same value. Condition number 1 is agreement, which says all non-faulty processors for P2, P3, P4 இதெல்லாம் non-faulty ன்னு வெச்சுக்கலாம். அப்போ இந்த P1 சொல்ற one value இதெல்லாம் agree பண்ணிக்கணும். That's what actually agreement. Then the validity, second condition is validity. All the other protocols la இதேதான் agreement validity ரெண்டுமே இருக்கும். Validity says if the source processor is non-faulty, then the common agreed upon value by all non-faulty processors should be the initial value of the source. அதேதான் validityங்கிறது இங்க when actually the source process communicates some value, all the other process must agree சொல்றோம். இது condition agree. If the source processor is sometimes faulty, then all other non-faulty processor can agree, come into agree a common value. So suppose source process faulty இருந்ததுன்னா அப்போ இது சொல்றது நம்ப முடியாது இல்லையா? அப்போ other processor will come up with an agreement of common value. Right? This is if there are faulty processor in the system, we need not to worry about what actually they are agreeing or whether they not agreeing any value or whatever. It is irrelevant. We need not to bother about the non-faulty processor. Sorry, faulty processors. That's what the point. And the consensus problem. Here the consensus problem, what I said already, as similar. So the processor, every processor is broadcasting. Right? So இப்ப இங்க வந்து பைஜன்டைன்ல இப்போ ஒரு சோர்ஸை நம்ம டெசிக்னேட் பண்ணுவோம் ஆர்பிட்ரரியா. இந்த சோர்ஸ் தான் இனிஷியல் வேல்யூவை சூஸ் பண்ணோம், இந்த இனிஷியல் வேல்யூவை பிராட்காஸ்ட் பண்ணோம் இல்லையா? பட் கன்சென்சஸ்ல அப்படி கிடையாது. ஹியர் எவ்ரி ப்ராசஸர் இஸ் பிராட்காஸ்டிங் இட்ஸ் ஓன் இனிஷியல் வேல்யூ டு ஆல் அதர் ப்ராசஸர்ஸ். இப்போ ஃபார் எக்ஸாம்பிள் இப்போ இது சோர்ஸும் கிடையாது, ரைட்? இப்போ என்ன நடக்கும்? 1 2 3 4 4 ப்ராசஸர் இருக்குன்னா இப்போ ஃபர்ஸ்ட் ப்ராசஸர் ப்ராட்காஸ்ட் எதிரி ஒன் இனிஷியல் வேல்யூ 1, செகண்ட் ப்ராசஸர் இனிஷியல் வேல்யூ 0னா அதை ப்ராட்காஸ்ட் பண்ணும். செகண்ட் ப்ராசஸர் அதோட இனிஷியல் வேல்யூவை ப்ராட்காஸ்ட் பண்ணும். இப்போ ஃபர்ஸ்ட் ப்ராசஸஸ் 1 ப்ராட்காஸ்ட் பண்ணிருக்கு. 3 will also broadcast its own initial value. Right? 4 will broadcast its own initial value to all the other processes. Okay? Mari broadcasting will happen. Right? Then the initial value of processes may be different. That's what I told you, know. So one initial value of 1 is 1, 2 is 0, 3 is 1, 4 is maybe 0 or 1, whatever. And the condition here is first the agreement condition. All non-faulty processor agree on same single value. Whatever is broadcasted by every individual processor, that is not going to be there is a complete freedom. But finally, all the processors must agree upon either a single value 1, 1 or 0. அப்படின்னா 1 இல்ல 0 agree பண்ணிக்கணும். இல்லையா? Okay. And then validity here says if the initial value of every non-faulty processor B in vechitona, then the agreed upon common value by all non-faulty processor must be V. Right? Okay. இதை தவிர வேற வேல்யூ இருக்க கூடாதுன்னு அர்த்தம். இப்போ 0னா suppose if you are permitting 0 or 1, அப்போ இப்ப இனிஷியல் வேல்யூ 0வோ இல்ல 1ஓ தான் எடுத்துப்போம் இல்லையா? அப்போ அக்ரி பண்ற வேல்யூ இதுல ஒண்ணுல ஏதாவது ஒண்ணா தான் இருக்கும். Right? That is what actually the condition. And here also some important note is given. If initial values of non-faulty processors are different, right? All the other processor agree upon a common value, right? Here also the faulty processor irunda we need not to care about. Then interactive consistency problem. So this problem also allows every processor broadcast its initial to value to all other processors. Now, and also the initial values may be different. Agreement condition here says all non-faulty processor agree on the same vector, right? And validity says if the ith processor is non-faulty and its initial value is VI அப்படின்னா, then the ith value to be agreed on by all non-faulty processors must be VI. இங்க என்ன சொல்றாங்கன்னா, so for example, there are 3 processors, 1, P1, P2, P3, right? Now, here there is a complete freedom that every processor can take up an initial value. For example, P1 assumes that the initial value is 1, P2 also 1, and P3 0 வச்சுக்கலாமா? So P1 will broadcast this value, initial value 1 to other 2 processors, P2, P3. Now, P2 similarly will share the value, broadcast the value, its own value 1 to P3 and P1. Similarly, P3 will share its initial value 0 to P1 and P2. Right? Now, what is here? The vector V equal to V1, V2 and V3. Here, what is V1? V1 is 1, V2 is 1, V3 is 0. Right? Appo, the vector assumption, right? So at every processor, இங்க என்ன சொல்லிருக்காங்கன்னா, if the ith processor is non-faulty, for example, P3, it is a non-faulty processor, right? So if it is non-faulty, its initial value, the initial value என்னவா இருக்கணும்? VI, right? Equal to the ith value. For example, in the 1, 1, 2 says 1, 3 says 0 னு agree பண்ணிக்கணும். இதே கன்சென்சஸ் ப்ராப்ளம் என்ன சொல்லும்? இது 3ல ஏதாவது ஒரு வேல்யூ அக்ரி பண்ணிப்பாங்க இல்லையா? இது 3ல எது மேக்ஸிமமோ அதை அக்ரி பண்ணிப்பாங்க. இங்க அப்படி கிடையாது, 3ஐ வெக்டாரா அக்ரி பண்ணி. இதே தான் ப்ராப்ளம் இன் கன்சென்சஸ்ல. பட் இந்த மூணுல ஏதாவது ஒன்று காமனா ஒரு வேல்யூவை அக்ரி பண்ணும் நான் ஃபால்ட்டி ப்ராசஸர். பட் இங்க வெக்டாரா அசியூம் பண்ணோம். பட் இப்போ சப்போஸ் இன் VI இன் P3 the vector is 0 1 0 தப்பு. பிகாஸ் for the processor ith processor first processor 1 the broadcasted value is 1. பட் இது எப்படி P3 வந்து 0 அக்ரி பண்ண கூடாது இல்லையா? அதுதான் the point, validity. Okay, if it is 0 1 0 தப்பு, 1 1 0 அக்ரி பண்ணிக்கணும். Okay, that's what the problem. Okay, now move on to the note. Here இங்க faulty processor இருந்தா we need not to care about anything, right? If the jth processor is faulty, then all non-faulty processor can agree any common value on VG. இப்போ என்ன சொல்ல வராங்கன்னா, இப்போ for example, okay, இந்த கேஸ்ல suppose இப்போ இந்த கேஸ்ல இங்க T processor. அப்போ what is இப்போ இது வந்து என்ன வேணாலும் வேல்யூ அனுப்புவீங்க 1 0 இதை பத்தி கண்டுக்க வேணாம். பட் for P2's location, ith location, this is P2's location. Here any common value, இப்போ P2 வந்து 1 அனுப்புது, இப்போ இங்க வந்து 1 அனுப்புது, இங்க 0 அனுப்புதுன்னு வச்சுக்கலாம். P1 க்கு 1ஐயும் P3 க்கு 0 அனுப்புது பிகாஸ் அது ஃபால்ட்டி ப்ராசஸர். அது இப்படிதான் அனுப்பும், மலிசியஸா அனுப்பும். அப்போ either 1 இல்லைன்னா 0. Okay, இப்போ at site P3 it's a non-faulty processor J, P3, the J is 3, P3 la if I'm taking that V3 equals, sorry, VI is 1 comma 1 is the one which is sent by P1. Here 3 is 0 because P3 is 0. Inga 2 sends 0 to P3 but 1 to P1. அப்போ நான் இங்க இருக்கிற that either common value should be there. இப்போ 1 ன்னு வெச்சிட்டோம்னா 1 ன்னு வெச்சுக்கணும், otherwise 0 ன்னு வெச்சுக்கணும். இப்போ நான் 0 ன்னு முடிவு பண்றேன்னா, right? So this is what actually the note is given. If any faulty processor is there, then for that position a common value should be agreed upon, right? So that's what the case. Okay, okay, so be clear, there are 3 classification. The first one says Byzantine problem. It's choosing an arbitrary source. That source selects the initial value and broadcasts to all other nodes, for which the other non-faulty processor must agree upon that common value, that single value, right? Here if any non-faulty processor there, need not to care about them. Then consensus problem here, every individual processor will select an initial value and broadcast that value to all other processors. Okay, and the initial values of processors may be different. For one processor may select 1 as initial value, other processor must say may select 0 as initial value. It is free, completely freedom. Condition here, all non-faulty processor must agree upon same single value. That's what the case here, right? இங்கேயும் faulty processor இருந்தா கண்டுக்க வேண்டியதில்லை. But when comes to the interactive consistency problem, it is similar to consensus problem, but the non-faulty processors are agree upon a vector, same vector. அவ்வளவுதான், same vector should be agreed upon. If suppose a faulty processor is there, for that position alone a common value should be assumed and agree upon. Okay, are you clear in 3D different problems? Now move on.